You are going to witness a simple but powerful magic trick. This is Guthrie, our resident magician. This is an ordinary stack of cards. Guthrie has pulled out a card, the Queen of Clubs. They cannot see that card, but you can. Guthrie puts the card into their magic wallet. They still cannot see the card. As you can see, the wallet is opaque on both the inside and the outside. Now Guthrie takes out their notepad and draws what they think you have seen. This is what they think you have seen. They pull out the card, still not facing them. But lo and behold, it matches their drawing perfectly. The Queen of Clubs. So, what do you think the trick was? Was it sleight of hand? Was it editing? Was it something else? Well, considering I'm not very good at editing, it must have been something else. And since this is a physics channel, you can expect this was a trick of physics. So I'll just let our resident magician show you what the trick is. Wait, did you just see that? That was transparent! This calls for some real physics. Since the lens goes from opaque to translucent and back, this is clearly a light trick. So let's draw a source of light, the tube light. And since we are far enough away from the tube light, we can model the light as parallel rays. And what do these rays consist of? These rays would consist of plain electromagnetic waves, which are waves where the electric and magnetic fields oscillate, and the electric field, the red lines, the magnetic field, the blue lines, and the direction of propagation, the x-axis, are perpendicular to each other. Note how in this animation we see that the energy or the electric field intensity which carries the energy is moving with respect to time, and the energy itself is moving along the x direction. Normal light that comes from the sun or tube lights or whatnot is unpolarized or randomly polarized, meaning the electric field is in random directions as long as it's still perpendicular to the direction of propagation. And so we have linearly polarized light where the electric field is in one direction versus unpolarized light. So if basically all natural light is unpolarized, how do we get linearly polarized light? Well, we use a device called a polarizer. Normally, it is just a string of molecules arranged in such a way that they absorb the electric field in all the directions and only emit electric field out in one direction. And that is linear polarization. Why do we even need polarized light? Well, there are some special minerals. They are not magic, but they are special, such that they have these crevasses and details to them such that they allow polarized light to pass through them, but only at some angles. And when the incident light upon them, which is polarized, remember it has to be polarized, does not pass through them, we call that extinction. And the incident angle at which that happens with respect to the details of the mineral, that's called the extinction angle. So when you put the mineral between two polarizers, you see the effect of the magic trick. It's an effect of extinction. And that's that.